Hi, everyone. Yeah, hope you can all hear me. It's a pleasure to be here, to be speaking to you. And I'm here to be talking about a tool called Digma, which is an IntelliJ plugin for continuous feedback. And I hope it will be clearer by the time that I'm done with the talk. Just a little bit about me and my background. I've been a developer for over 25 years. I actually started with Java. It was my first language, first love, as you say. Transitioned through many other languages, eventually coming back to Java recently and found out that it's actually so much better. And to some extent, although it doesn't sound that well, I think this tool, this plugin came out of a lot of frustration that I've experienced over the year. I'm a little bit of a frustrated developer. I'll explain, and I hope that not too much of the frustration will come out during this talk, although fair warning, it might. But it's all in good spirit. So a little bit about the inception story for Digma. I kind of got in trouble a couple of times because people told me, hey, you said you started Digma when this happened, but then you told a completely other story. And it's all true, because Digma has kind of this death by 1,000 paper cuts type of an inception story, where it was not even one thing, it was a lot of different things that I started noticing in our development process that really drove me a little bit mad. And here's the gist of it, and I'll come back to it, but at the very kind of essence, what I noticed is that there's a whole lot of things that I can know about my code that I mostly find out after the fact. And I've always invested a lot in the latest and greatest logs, observability, providers, everything. But when it came down to it, when I was using all of that important data, was mostly after the fact. And then, compared to that, there is a very small amount of things that I could know about my code and how it behaved. And they came from tests, from debugging, from maybe some other sources, maybe tribal knowledge inside the organization. And I was frustrated by it because I thought, well, how can we make that circle larger? How can we get more of that data that's already there, right? How come every time we did like a debrief or tried to kind of retrospect on an issue that happened, we said, oh, of course, the log said that this service shouldn't have been talking to that, or there's a big recursion here. Why is it that we always found that after the fact? And it doesn't help that code is complex, and a lot of code, and I think there are other sessions on this topic that I saw that I actually wanted to listen to as well. Code kind of accrues layers and gains, loses a lot of its integrity over time. People that wrote it go away. And it becomes a challenge to understand not just how the code changes are impacting production or what type of issues may be introduced here, but just to understand how the code runs. And if you don't know, and I did not know on many occasions, if you don't have access to that larger circle, to all of that knowledge about the code, then you just spend a lot of time troubleshooting. Then you start trying to refigure out the obvious every single time. And here, my frustration started building up. Now, there is a bit of an anomaly here, because on the one hand, I'm a big proponent of continuous deployment, of accelerating releases and so on. But on the other hand, it seemed like without feedback, all you're doing when you're moving towards faster releases is throwing features over the fence at a higher rate, maybe. So I was looking for something else. I was looking for faster feedback loops. That means that me as a developer can get that information as fast as possible, and I don't need to talk about it in retrospect. So I went back to the sources and kind of, by the way, this is one of the first images that will jump at you if you Google like the DevOps loop. And I found something peculiar about it. Now, if I also have a session on Thursday where I'll specifically be talking about how to use information about your code to improve your code, irregardless of Digma, which is a tool that helps with it. But I noticed something absolutely weird about this diagram, and that there is a big hole right in the middle of it. If you'll see, there are tools attached to practically every phase of the DevOps process. But right in the middle, there is a continuous feedback category. The author of this particular diagram saw fit to include Salesforce as the tool of choice there. I actually wrote him a very polite email asking if he had some reasoning behind it, but did not receive a reply. But the thing is, this is what I was looking for. Like, this is the movement that is kind of the inverse of the CI movement, where it's not taking code into production, it's taking data about the code back into code and planning. And this is what got me thinking. So, like, what are our sources of feedback today? What kind of feedback can I get as a developer to solve this problem? So, we have debugging, which is great, but it has its shortcomings. Debugging is kind of reactive by definition. If you're debugging an issue that already you're noticing. You can't debug just out of trying to understand how something you can, but it's not very scalable. It's detached, so like if you leave a debugging breakpoint somewhere, you're seeing that specific thread at that specific instance at that specific point in time. Again, not very useful if the problem is on request 224 or whatnot. And it's manual. And then we have testing, and testing is great. I love testing. If you're not testing, please test. It's required. It helps. But testing have their own limitations, and specifically the fact that we use very little of the data that the tests generate. And what I mean by that is that we look if the tests succeed or fail, or if they validate our assertions, but that's all. And it's a big waste, okay? Second frustration coming out, because there's so much data that we're creating when we're running our code with integration tests. And by the way, test containers, other technologies made integration tests so much easier. But we're only looking at the tip of the iceberg, which is the specific assertion that I selected, which is often prone to biases. Did that actually succeed? And then we have runtime data, also known as observability. And the first response that I get from many developers when I talk about runtime data is, wait, that's a DevOps thing, right? That sounds complicated. And this is where I'm really frustrated. Because, there are so many ways that we can use that data. And then somewhere along the line, somebody decided, you know what? Let the DevOps and SREs worry about the observability, and let developers work with tests or with debugging or whatnot. And it's not that developers don't go to these dashboards. They just go there after the fact. And dashboards are a great idea, but not for every use case. And there are several problems with it. The first one is that when you look at a dashboard, to understand how it relates to your code requires a lot of mental steps. Is 100% CPU utilization good or bad? I don't know. It depends on the use case, right? How do you discern if something is anomalous, if there is an issue here that should be resolved that's related to one of your code changes or not? There are a lot of issues with actually taking the raw data, if it's in a dashboard, if it's in a trace, like a list of traces or logs, and translating that into something that you can actually use. And because of that big cognitive leap or gap, developers don't use it that much. And because of that, you may notice that it's not really continuous. So dashboards are kind of the opposite of continuous feedback. They're on-demand feedback. So not quite what we're looking for. So this was what I was thinking when I set out to create Digma. We need something simple without any prerequisites. Why? Because developers would, if it had a lot of involved setup, or if it needs changes in the code, it becomes a project. It becomes something that I need to approve with somebody. And the way I selected to do that is through an IDE plugin. So we created an IntelliJ plugin that's all-inclusive, that basically you install the plugin and you have Digma. The other aspect is how do we make that understandable, which means that I don't get a list of logs and traces and I now have to understand what it means about my code. It is about my code, and it is telling me about my code what these traces and logs that I can collect automatically tell me. And finally, continuous, right? I'm frustrated because I remember the same thing with testing. I'm kind of old enough to remember when testing were not continuous, and the thing is, they didn't happen. Nobody out of their willingness of their heart would just kind of try to create trouble for himself by running tests manually and understanding all of the issues. And it's the same with observability. How can we require or ask developers out of the kindness of their hearts to probe around traces and metrics and logs just so they find something to fix? Some people are like that. But most developers aren't. So with that, let's see how we took a stab at it. And just to prefix this, Digma is free. We'll get back to that. So developers can use it, no problem, commercial or personal projects. And it's available on the marketplace. And it's also local. So it's not sending any data out. So I have my IDE here open. I've actually pre-installed Digma, but I can kind of explain what it takes. It's basically just going to the marketplace and searching for Digma. That's basically that. Once you install Digma, we actually look at 3 different things that we need to accomplish. The first is how do we make it as seamless as possible to start collecting data about the code. And here, fortunately, we had some great advancement with OpenTelemetry. So OpenTelemetry, for those of you who are familiar with it, is a technology that allows you to collect metrics, logs, traces, and so on. Now, the thing about OpenTelemetry is that I think developers shouldn't really know anything about OpenTelemetry. Why? Because it's just the technology behind the scenes. It's kind of like how the watch works. And it's the output that should concern them. So we've reduced that down, and now that I've installed the IDE plugin, you can see that I have kind of an observability toggle, on and off. That's it. And if I turn it on, then now when I run tests or debug or kind of run my code, Digma will automatically start collecting data. It will use the OpenTelemetry agent for it by default, although it has other strategies like Micrometer, for those of you familiar with it. And basically, I will start collecting data. So first step is accomplished. We now can collect data even in dev and test. The second phase is what do we do with that data? So in this case, I'm using the Pet Clinic app, but since I am kind of wary of apps that are basically CRUD or too cruddy, I added some additional functionality to check the vaccination status of animals and things like that. So I added a mock API, I added some checkups, and I can actually add another pet, and things will happen to check that the vaccination status, whether I need another vaccine or not. So far, so good. Now, I've also ran some tests. So I've created some test containers, a test. I've run it. Everything is working. And now I go back to my previous question. What do I know about this code? So let's think about the big circle and the small circle. I've run my tests. So I know my validations are true. I have actually debugged it maybe a couple of times, so I know some things about how it functions, and I can look at static analysis tools, right, to see that I didn't make a glaring mistake in styling or, I don't know, formatting or whatnot. What can I know about this code? So as I was doing this little exercise, you may notice that there's a green dot that appeared here in my IDE. And this means that Digma started collecting information. It started collecting data. And the big circle, what I could know about this code, that's amazing. Because over here, there's a lot of stuff that I should know. And if I just opened up this view, and hopefully you can all see it, you can see the things that Digma started recording about my code. So let's take an example of a specific piece of code and what we found. And by the way, this entire kind of, all of these flows become kind of a living documentation. So they're kind of a part of my view and all the time. So it is continuous. It's coming frequently. There's notifications that tell me what's going on, and immediately I can see issues. Let me make this a little bigger. So the first thing, not surprising, I was actually using Hibernate and experiencing some N+1 issues. Could I have known that? Yes. Would I have tested it? Not always. There is an open session in Vue. For those of you familiar with it, basically, as I'm rendering the view, I'm accessing some lazy properties and triggering queries, not something that is considered the best practice. So I'm now aware of that as well. And I can start seeing information that was previously invisible to me. And here is my frustration. That information was there all along. And these are just examples of the type of data that was there all along. It was lurking in the observability, and I had no access to it. Now, what did we do? Nothing. We installed a plugin. We enabled observability as we were debugging. I'll go into CI and production in a sec. And immediately, inside my IDE, I can see exactly how my code is behaving. And in this case, let's take one of these issues. Let's take the N+1 issue. I can make that completely kind of integrated into my code. So I can see, OK, what is the query that's causing the problem? Which endpoints actually use it and are affected by it? And I can get to, like, let's say, a specific trace of what does that issue look like. And let's make that a little bigger. So we've inversed the pyramid. Instead of saying, hey, let's lurk around dashboards and lists and find issues, let's first find the issues. And in this case, we use the second thing that changed. The first one was OpenTelemetry. The second is that machine learning is much more accessible. So we can actually process all of the data and find patterns, issues, anomalies, and so on. And then we can begin from those issues, and now if we need to explore, we can go to the trace and start knowing the code. So I can know how this code works. I can know how the request works. And of course, when you look at it like that, the N+1 issue is pretty obvious. But in order to make it usable, I had to kind of inverse the order. So I do not require developers to just manually and in a very detached way kind of access different sources of information. Now, if I look at my CI is also offering me some interesting insights about this code. So, for example, in my CI, I'm already testing the performance at scale. And here, I can see that this specific code is scaling badly. Why is that important? It's important for me to know anywhere, right? If I'm going to touch a piece of code, I want to know where the bottlenecks are. And we talked about different types of insights here, right? Before I was talking about anti-patterns like query issues and different things that I probably don't want to check in. Now we're talking about performance and bottlenecks and scalability. And we can go, again, and explore and understand, OK, this is the root cause, which is basically the validate owner with external service. Okay, that sounds like a likely culprit. And we can see exactly where the scalability or the bad scaling is happening. But again, the point is that I would not have had any access to that information unless it's after the fact. Now, in order to do that, we had to decide on several things. First of all, we said, let's concentrate just on Java. Why? Because there are specific issues that Java developers are facing, and we need to make this as valuable as possible and based on kind of a from the trenches type of insights and not make up our own ideas of what they would be. Because if you think about it, like one of the main issues that you face if you're just using a generic API is that you now need to understand if something is bad or good or how bad and good. And in this case, we can use the knowledge of the community. The other aspect is that we had to make it very integrated into the code because it is essentially code-centric. So the code is really in the middle of it. When I look at a specific trace and I try to understand like something specific about the trace, I want to be able, I want to be able to navigate into the code from the trace and understand exactly where that is happening. So instead of having one world, which is the world of dashboards and metrics and lists, and another world, which is my code, let's try to connect them. So how does it work? Digma runs locally. This is one of the early decisions that we made. Why? Because people are kind of wary about their observability data, and for good cause. So they would not feel comfortable sending loads of data into the cloud and then getting back results, as much as that would simplify things. So from our perspective, we decided we would run everything locally, containerized, by the plugin, and to the outside world, we present two interfaces. One is a collector, and a collector is an OpenTelemetry construct, and basically it can receive observability data. That means that we can receive data both that we generate ourselves, like in the IDE, when I just clicked run or debug, we know how to add additional environment variables that would allow the Java agent to be used and for observability to be collected. And then on the other end, we expose our own kind of API endpoint to query that data that our plugin is using. And all of that is running locally on your machine. And if you run it in your organization and you want to, let's say, send data from CI or production into it, then you can just run it as a Helm chart anywhere. And then on the other hand, we have the plugin. And the plugin is kind of very simple and integrated into IntelliJ. We're currently supporting only IntelliJ, but we'll probably expand that as we move on. It's just that it seemed like most of Java developers use that specific IDE. So before I move on to questions, here are the main takeaways. So first of all, it's free. And it's in the marketplace, and it's free for developers always. Organizations that will want to use it, we have a pricing model for that, but we're not a very, we're not a Datadog or kind of any big vendor. We're a developer tool, so the pricing is accordingly. But if you're a developer and you want to use it in a commercial product or personal project, you don't need a license. You can just use it. It runs locally, and it doesn't send any creepy data to the cloud. That was a requirement. And you don't need to know anything about OTEL. And this is kind of my last frustration. I've talked to many developers, and I explained what we do to them. I said, well, OTEL, yeah, that sounds like a DevOps thing. So no, if you don't use OTEL, that's fine. One of the benefits of OpenTelemetry, and I think that's the major breakthrough that OpenTelemetry made, is that everybody agrees on it, And as a result, there is a massive support in libraries for it. So that means that instead of adding manual instrumentation, which you can still do, you also have automatic instrumentations by many of the libraries. So if you're using Quarkus, if you're using Spring, if you're using Spring Data, if you're using JDBC, if you're using Kafka or RabbitMQ, if you're using HTTP or OKHTTP or whatever library you're using, a vast percentage of them already have that data. And that's the magic, right? Because the magic was, hey, I just downloaded a plugin, and I just had, like, I met, I was doing a short webinar before, and we were just working on a new project, nothing that I've ever seen before. And immediately we saw a lot of data. And the magic is simply that all of these libraries already integrate with OpenTelemetry and already have exporters. So from the agent perspective, it's just very easy to pull that data, and we can get massive amounts of data, almost too much data, without worrying about it. And lastly, the distribution model is simple. It's just available on the IntelliJ marketplace. You can get it from there, install it, and play around with it. Now, happy to answer questions before we conclude. Any questions? Yes.
Is there a documentation or something where we can see the list of possible issues which this tool will cover?
There is a documentation. Unfortunately, it's still in our community, so we haven't posted it. You can join our community. It's just a Slack group. If you install Digma, you can join it. But we're working on that documentation with our community, and when it's ready, we'll post it. But just to give a few examples, it is regressions in terms of times. It is query issues, security issues with queries, or queries that are suffering from, let's say, a select n+1. It is errors and error hotspots. I didn't show that, but you can actually get to specific errors and travel the call stack and understand where it's happening, but also analyze where the hotspots are in terms of errors, what is escalating, what is increasing, and so on. There are analytics related to usage, like who's using this code in runtime, who might break if I change it. And this is, of course, distributed, so it's across microservices. Yep. We're working on Kotlin at the moment, and hopefully Scala will be after that. It's not that hard to add the support for additional JVM languages. Yep. Anyone else? Yeah?
Have you tested this plugin with, let's say, frameworks instead of an application?
Like running it on the framework itself?
Yeah.
Yeah, I think the optimizations are a bit different sometimes. I'll give you an example. Did anyone here attend the optimization session by Red Hat about the JVM optimization? I think they were discussing using a sync profiler. So if you're writing a library or a lower level framework, then you're probably concerned with many things that are more low level, like inlining or heap allocations for strings and things like that. But if you're writing an application, then usually it's these really dwarf in relation to the libraries you're using and whether you're using them correctly. And I think so far we're mostly concentrated here on kind of the code on a high-level perspective. But definitely after the session that I attended about async profile, it was really interesting. We're looking into expanding that later. Cool. Any other question? Yes, but you'll need to.
Decide what is slow. So it was written slow query.
Yeah.
Mm-hmm.
That's a great question, and there are several ways that we have to use in parallel in order to make that decision. First, we need to understand how it behaves based relative to other queries in your application. So other selects, okay? So if it's a more complex select that is non-indexed data, it will behave a bit differently. So it will kind of, the divergence from the norm is really important. The other aspect is there are some constraints in place when you think about how much should a database query take that we need to also kind of factor in. And the other is the baseline of the query itself, because let's say the query itself, you made a change to it, and then because of that, suddenly it's much slower, then that's a very interesting piece of data to take account of. But in general, and also when we look at the data, what we try to do is ask ourselves, if an expert developer would be looking at all of the traces and logs and looking at that data, and we had to talk to a lot of developers to get to that conclusion, what would be the things that they would spot and how they would do that? And then, can an AI spot the same things and how? Cool. I have, I think, time for one last question. Yeah?
So if I want to play around with Digma on my existing code base,
Mm-hmm.
all I have to do is install the plugin from the IntelliJ marketplace, or do I have to spin up a Docker container in the background as well to host the engine? Or
So the plugin will do that. It will also give you complete control if you want to stop, start, remove the containers that it's using. We elected to run everything locally. It's not doing anything when you're not running code and sending data to it, and you can also stop the observability. But we elected to do that just to make sure that you don't need to sign to a SaaS service and worry about compliances and other things. And we don't want that responsibility right now of handling other people's data. So for that purpose, you basically, Digma will actually take care of installing that for you. If you go, you can actually see where it's installed, and you can remove it or stop it. So all of that functionality is kind of built in. And it's pretty, like when you're not sending data to it, it will probably not bother you at all. If you are sending to data, there will be a little bit of an overhead when it crunches the numbers and runs the models to see some conclusions. And of course, if you want to use it at scale, so start kind of sending a lot more data into it, then you might want to consider installing it via a hem file in a more central location.
makes sense. Does it collect data from unit test runs as well, or only when you...
Yes. So like one of the things, I use Digma with test containers. And test containers are awesome because they generate this integration test that really tests the service and how it's working. And this is kind of where I think they can provide a lot more benefit than just the validation, because if you think about it, an integration test running in a CI is the perfect experiment because you've locked down all of the factors and just the code is changing. So it's much easier to find any changes that you want to look after. But the goal, again, is to be more productive, is to get faster feedback on things that you're doing so that you don't encounter them later and don't spend time troubleshooting them, but also to make sense of the code, because a lot of the time, the observability can actually show us how the code works.
Thanks.
Cool. So thanks, everyone. I do hope you try it. And if you do, please let me know. There is, as soon as you kind of complete you can the installation, you can click the Digma channel here to join our Slack, where I'm usually the first one to greet newcomers, although I've been kind of, it's been getting increasingly hard to keep pace, to keep up with the new users. But definitely would be happy to answer any questions and continue talking there. Thanks a lot, guys.